Let's discuss uniform circular motion. Problem 1. A highway curve with a radius of 300 meters. So this R here is 300 meters. And this highway is banked at an angle of alpha, so that a car, denoted here, is moving at 25 meters per second. And this car will not skid sideways. So assume the surface is frictionless, so that is the surface on which the car is. At what angle should the curve be banked? Note that this is a cross-sectional diagram, so the car will be moving at a banked angle in a circular motion, like that. Let's first identify all the forces that's acting on this car, so free body diagram that is. The first one, the obvious one that is the weight of the car, which act vertically downward. So weight equals the mass of the car times gravitational acceleration. The second is the normal force from the surface of the highway on the car, 90 degrees, with respect to the surface of the highway. And let's label that N. Now the surface is frictionless, so you don't have to worry about friction. And we want to determine the angle alpha that avoids any skidding motion, any sideways skidding motion for this car, like that. One thing to understand is this is a circular motion, a uniform circular motion. So at this point, the car could be moving with speed v meter per second. That means there is a centripetal acceleration in that direction. Let's call it AC. So it goes horizontally from the car to the center of the trajectory of that circular motion. So this angle has got to be alpha, and that angle there is 90 minus alpha. So that is this angle. For a uniform circular motion, such as this one, there has got to be a centripetal force. The centripetal force is quite simply net force acting on the object, in this case the car. And the expression is given by mass, the centripetal acceleration. So it is just Newton's second law. Mass, let's just assume it's m. Centripetal acceleration is the speed of the car squared over the radius of that circle. What contributes this net force? As you can see, there is only one, the component of this normal force along that direction. So what is it? It is quite simply n cosine of this angle. Cosine of 90 minus alpha is sine alpha. Note that we have few variables in this equation. We don't know the mass of the car, alpha is what you want to determine, and you have the normal force in that car. Let's see if we can find another equation. Consider the forces acting along the vertical direction. There are two. One is the weight, and the other one is the component of that normal force along that direction. Now this angle here is alpha. So the component of normal force in a vertical direction has got to be n cosine alpha. And cosine alpha must balance the weight. So we have a second equation. N cosine alpha equals weight. So equation 1, equation 2. Let's take equation 1, divide equation 2. So you see that n will cancel each other, because you have n sine alpha over n cosine alpha equals, the right hand side would be mv squared over r over mg. So n goes away, m goes away, and you get tangent alpha on the left hand side equals a v squared over g times r. Now we require the car to move the speed of 25 meters per second. So 25 squared. G is 9.81, and the radius is given to be 300 meters, 300. And tangent alpha will become 0.212, from which alpha is found to be about 12 degrees. And that's the answer. Problem 2. A string is tied to a pail of water. That's this object right there. And is swung in a vertical circle with a radius 0.9 meter. So R is 0.9 meter. Find the minimum speed of the pail at the highest point of the circle if no water is to spill from it. So when this pail gets to the topmost position, what should the speed be, the speed of this uniform circular motion be, in order to avoid any spill of water from the pail? Let's analyze all the forces. The free body diagram that's acting on this pail of water. At the topmost position, of course, its speed is v, which we don't know. Now there's weight of this pail along with the content of the water that acts downward. Let's call that mg. And there's also the tension in the cord that's acting downward. And there is a centripetal acceleration towards the center because it's a uniform circular motion. So that means the net force on this pail of water is quite simply tension plus the weight. And that must be m times centripetal acceleration. So tension plus weight equals mass v squared over radius. So v squared over radius is quite simply the centripetal acceleration. In order to find the minimum speed of the pail at the highest point, if no water were to spill from it, that will happen when the tension is about to go to zero. So if the tension is not zero, then it will just continue like that. It's about to go to zero, it will still make the trajectory to the other side, but that is the threshold, and after that the water would spill. So we shall set t equals to 0 in order to find that minimum speed of that pail, that threshold, and figure out what the v is. So you see, when you set t to 0, the equation gives you mv squared over r equals mg. So the mass cancels, you don't need to know the mass, and this v here is actually v minimum, which can be solved from the following equations. V minimum is square root g times r. Now g is 9.81. The radius was set at 0.9, and when you solve this, you will get 2.97 meter per second, and that solves the problem. Problem 3. In figure below, this mass here is connected to two massless cords, the upper cord and the lower cord. And the mass has a value of 1.4 kg. This L here is 2 meters. The value of D is also 2 meters. The mass is rotating about the vertical axis as shown. So this is the vertical axis, and the rotation is like that. The tension in the upper cord is 38 newtons. So that is the tension in the upper cord. Find the tension in the lower cord, the speed of the mass, and the net force on the mass. Let's identify all the forces on this mass. So we are constructing the free body diagram. The first one is the weight. So the weight is 1.4 times gravity. And then you have this tension in the upper cord, which we know to be 38 newtons. The tension in the lower cord, we don't know. We can label it as TL. Note that this mass is going like that, in a circle like that. So there must be a centripetal acceleration at this point towards the center. So you can sketch the centripetal acceleration to be A sub c. Now you can take that direction to be the y-axis and that direction to be the x-axis. Let's first determine the values of alpha and also the radius of that circular trajectory, capital R. Note that in the triangle, since this is L, this is d over 2, so that is d over 2 from the geometry of the situation. This is R. You see that R is quite simply L squared minus d squared over 4. Since L and d are the same, this will simply become square root 3 over 2, say L. So R is square root 3 over 2 L, where L is 2. Now what about alpha? Now cosine alpha is given by R over L. So that means since R is given by this expression, cosine alpha is square root 3 over 2. Now what about sine alpha? Sine alpha is given by d over 2 over L. Since d equals to L, it is quite simply half. So let's record all these quantities to the corners. R will simply become square root 3 because L is 2. Cosine alpha is square root 3 over 2 and sine alpha is half. Let's look at the forces along the x direction. Now there are two, the x component of the upper tension and the x component of the lower tension. And we can write the x component of the upper tension to be 38 cosine of alpha, which is square root 3 over 2, plus the lower tension, cosine of alpha, again square root 3 over 2, and that provides the centripetal acceleration, which is the mass of the object, we know, 1.4 kg, speed squared over the radius, r, which is square root 3. So you have equation 1. So equation 1 is square root 3 over 2, 38 plus lower tension equals mass is 1.4 over square root 3 v squared. Equation 1. Now let's analyze the force or forces along the y direction. And there are three. The y component of upper tension, the y component of the lower tension, and the weight. So the y component of the upper tension is 38 sine alpha, which is half, and it's balanced by the y component of the lower tension, which is TL sine alpha, half, that is, plus the weight, and weight is 1.4 g. So that's equation 2. Note the y component of the upper tension goes that way, the y component of the lower tension goes that way, so this must be the same as this plus that. Immediately from equation 2 you can determine the lower tension, and you'll get the following value, 10.53 newtons. Note that G is taken to be 9.81. Now substituting this value in equation 2, because equation 2 contains the lower tension, so the lower tension is T sub L, Substituting this value in here, you can get the speed, which will be 7.21 meter per second. So that's answer for part B. Now, the net force on the mass. The net force is along that direction. So the net force is given by the centripetal force, which is mass times speed squared over radius. Mass is 1.4, speed is 7.21 squared over square root 3, and that's going to give you 42 newtons, and that solves the problem.